qualitative analysis. वही पुराना गाना. Is NaCl soluble in water? Is NaCl soluble in water? Can you dissolve 500 grams of NaCl in 1 liter water? Max, it is 350 grams. So, yes, to some extent. Maybe large. Qualitative analysis and practical organic chemistry, you are likely to get 2 questions, 3. Maybe large. Is AgCl soluble in water? Yes, to some extent. Maybe 1 picogram in million liters of water. Yes, to some extent. Maybe small. This class is quite unplanned for me. Only the day before yesterday I was told. Right? Suppose 3-4 दिन 24 घंटा हम बारिश में भीग गए, क्या होगा? बीमारी तो हो गई. किसको? किसी को भी होगा. लेकिन जैसे मुंबई में बादल चालू होता है, यहां जुकाम किसी को लगेगा? There will be 1 or 2 people and they become famous for that or infamous for that. So, similarly, if we eat tons and tons of hara mirch, explosion takes place, doesn't it? But just by looking at hara mirch from 1 kilometer distance, हाँ करके कोई बेहोश होगा. There will be people like that also. So, similarly, you take NaOH solution, aqueous NaOH solution. Add HCl gas to it. Does NaCl get precipitated? 1 mole, 2 moles, 10 moles, 100 moles. एक हद होगा, लेकिन NaCl कभी न कभी प्रेसिपिटेट हो ही जाएगा. इसका मतलब लार्ज अमाउंट ऑफ क्लोराइड आयंस ऐड किया तो कोई भी प्रेसिपिटेट होगा. लेकिन स्मेल ऑफ क्लोराइड आयंस, जैसे क्लोराइड आयन स्मेल दिखाया, प्रेसिपिटेट होने वाला बहुत कम लोग होंगे, लेकिन होंगे. So, first solubility group, these are not periodic groups, solubility group. First solubility group, dilute HCl. What does it provide? Very few chloride ions. Very few chloride ions. Some of you must be listening for the 3rd time. Kahani. Now, so, बहुत कम chloride. All chlorides are highly soluble. Nitrates are, all nitrates are soluble in all proportions. Jitna bhi mila, 100 kilo nitrate is soluble in water. Any amount of nitrates are soluble. All chlorates are soluble except lead and silver. And there is one other cation, Hg2 2+, but that is not there in our syllabus. Ag, Haji, Pilao Bhai. Ag, Haji. वो syllabus में नहीं है. So you get a precipitate. The color is not important. Black and white colors you need never need to remember. Now, and when the precipitate is heated, it dissolves. You get a precipitate on heating, no action. So, how do you know that silver ions are present in this bottle of water? Silver ions. How to identify them? Add dilute HCl, you get a precipitate, heat, and nothing will happen. Even after heating, the precipitate doesn't dissolve. So then you can, there are no confirmatory tests for silver and lead, thankfully. So suppose nothing happens when dilute HCl is added. You need not throw the test tube out. You add H2S to that. Dilute HCl plus H2S gas. What does it provide? Very, very few sulfide ions. I have written very, very 2 times because there will be another group where there are very few sulfide ions. Now, H2S is a what? Weak acid. Doesn't produce many H plus and S2 minus. Of course, we are not interested in H plus in this particular case. What we require are sulfide ions. They are already very few. They become fewer still in presence of who? HCl, due to very good common ion effect. H2S ionizes to give aqueous this time. 2H plus and S2 minus, HCl aqueous, H plus and Cl minus. There is no equilibrium here. And this is the common ion because one of the components of the products is more. Here backward reaction will take place and sulfide ions they become fewer still. So बहुत ज़्यादा सल्फाइड ऐड किया तो कोई भी प्रेसिपिटेट होगा. दिस इज व्हाट आई वांट टू हियर. बहुत ज़्यादा सल्फाइड ऐड किया तो कोई भी प्रेसिपिटेट होगा. स्मेल ऑफ सल्फाइड आयंस, वेरी फ्यू पीपल गेट प्रेसिपिटेटेड एंड दे आर none other than copper 2, mercury 2 and bismuth 3. You get a precipitate, and you know most of the sulfides are black, and you remember the question of 2014, how many sulfides are black? Among 9, they say it is 7 or 8. 6 or 7 somehow. So how can it be 6 or 7? Do they have color blindness? I do not know. And ammonia, when added in excess, not necessary to write excess, ammonia, you get a deep blue complex. What is that? Cu NH3 4 times 2 plus tetramine copper 2. With mercury, you once again get a precipitate. I think that is also bleak. And cobalt thiocyanide, you get HCO, Hg, SCN 4. Okay, and this is a blue complex once again. Is it a complex of cobalt or mercury? For getting a complex of cobalt, you need not take mercury. If you put cobalt thiocyanide itself in water, it will give the complex, if at all it is a cobalt complex. Now, you get a precipitate, and when Ki is added, you get BiI3. I don't know what color is that. Black. Good. Black. And excess Ki, orange. BiI4 minus. Very strange. Bismuth accepting a pair of electrons. How many got selected here? And all of you, of course, in prime Pune. Mains. More than 250. Now, and this one is orange. Orange, yellow are always misleading. Yellow, orange, red. Now you may have to throw back the test tube. NH4OH and NH4Cl. What does it produce? Very few hydroxide ions. Listen, in this particular topic, we try to minimize the number of ions because large number of hydroxides will precipitate anybody. Even sodium hydroxide also gets precipitated at some point. I think it is 750 grams per liter. Iska threshold. Now, why is the number of hydroxide very few? There are two reasons. Ammonium hydroxide, yes please, is a weak base. How do you know it's a weak base, my dear friends? Calcium hydroxide, is it a strong base or a weak base?
Weak.
How do you know?
Sir, you gave 6 hydroxide.
Yeah. It's not tossing a coin. Only 6 are strong bases and only 6 are strong acids. And who classified that? Brownstedt-Lowry, no one else. Now, produces very few hydroxide ions. They become fewer still in presence of ammonium chloride due to common ion effect. I think my handwriting has improved a lot. Last time it was gullible. NH4OH, NH4 plus, OH minus, NH4Cl. No equilibrium here. And this is the common ion. and the ionization of ammonium hydroxide is suppressed. So when you add large number of hydroxide ions, anyone gets precipitated, but few hydroxides will precipitate only a few people, one of them being aluminium 3+, chromium 3+, iron 3+. You get a precipitate. What could that precipitate be? Naturally aluminum hydroxide. It has got precipitated with OH, aluminum hydroxide. And when you add NaOH, it dissolves. However, base reacting with a base, very funny. What is that nature called? Amphoteric nature. It's not exactly a base. Aluminum hydroxide is both acidic and basic. So it can react with both acids and bases. Now, chromium 3+ is of course green precipitate. Wherever it is required, you have to remember the colors. I in fact gave you a list, and today also I give you a list, 20 compounds and their colors. And of course the reactions have to be predicted by that color. H2O2. Who is H2O2, my dear friends? Oxidizing agent, reducing agent, bleaching agent, antiseptic, water purifier, what not? Acid. Now, you get CrO4 2-, chromate, and chromates are yellow. When you add acidic medium, chromates are converted to dichromates, orange. And of course, dichromates in basic medium are converted to chromates. And the CrO4 2- is treated with lead acetate. You get lead chromate. This is no conformation, and this is yellow precipitate. Why do we do this? If you remember, tell me. Huh? It's used as an evidence. Suppose somebody is killed by chromate poisoning. Chromate poisoning. Chromate is poisonous. And the waters of Yamuna are full of chromates and dichromates because of the tanneries in Kanpur. Now, and when a post-mortem is done, and of course it is done in presence of a magistrate, but the case will come to court maybe after 6 or 7 years. So you have to provide evidence at that time. So what the doctor will say is, whatever blood sample you have given, sir, from that I have made this, which tells that the original sample contains chromate and sodium thiocyanate, CNS, thiocyanate. Cn- is cyanide, Nc- is isocyanide, CnO- is cyanate, CNS- is thiocyanate, and NCS- is isothiocyanate. SCN- thiocyanate, simply thiocyanate. You get a precipitate, reddish brown. And with NaCNS, you get blood red due to the formation of FeCNS 6 times 3-. Hexa thiocyanato-ferrate 3. These are the three main groups. Others are rather peripheral. Group 4. How do you get dichromate from chromate? Any idea? Dichromate from chromate. Very good. Acidic medium में क्या बनता है? You get HCrO4 and that undergoes dehydration, intermolecular dehydration. It's like pyro. It's like pyro. It's dimerization. NH4OH. Group 2 is called, please make a note, in group 2. Group 2, very important. H2S in mineral acid medium. This terminology is very important. H2S in mineral acid medium. NH4OH plus H2S. This time H2S in alkaline medium. A few more sulfide ions. Listen, 100 sulfide ions will precipitate any one. One sulfide will precipitate only copper, mercury and bismuth. 10 sulfides will precipitate zinc and manganese. A few more. Why has it increased this time? This is acid, this is base. H2S, NH4OH encourages the ionization of H2S. Why do you think that happens? Very good. पानी बन गए तो heat release होगा and that heat will further ionize H2S because of that heat of neutralization. Now, zinc 2, manganese 2. You get a precipitate, and the precipitate of course is zinc sulfide, and when NaOH is added, the precipitate dissolves. Once again, amphoteric nature. So how do you distinguish zinc and aluminium? Precipitated as a hydroxide in third group. This one is precipitated as a sulfide. Sulfide precipitate of sulfide. Mn2 plus, the precipitate itself is of buff color. Pink. The color of sand, so to say. Muddy water. You never get that precipitate. Have you read reactivity thoroughly? Reactivity. You might even watch the video. And how much of inorganic was there in mains? I don't think much, no? 7. Mostly it's physical, is it? I haven't gone through the paper completely because I haven't got interesting students this year. Nobody turned after the exam. like the remaining 200 people here. Group 5. Ammonium carbonate, ammonium chloride. What does the combination produce? Very few carbonate ions. It's calcium and barium. Group 5. You get a milky white precipitate of calcium carbonate. Milky white precipitate, and when carbon dioxide is added, dissolves. The precipitate dissolves. Barium, you get a precipitate with CO2 no action. What is the best question of inorganic mains?
Basic carbonate.
Basic?
Carbonate. Similarities between lithium and magnesium. Similarities between lithium and magnesium.
Oh, diagonal relationship. Group 6. We have only one cation in that group 6. That is magnesium. Magnesium 2 plus, we don't require a combination of reagents here. Disodium hydrogen phosphate, you get a precipitate. Means all hydrogen phosphates are soluble except that of magnesium. Hydrogen phosphates are highly soluble, while phosphates are not at all soluble. Disodium hydrogen phosphate. Group 7, ammonia, ammonium hydroxide, ammonium ion, any ammonium compound. What do you know about any ammonium compound? Sorry?
On heating we get it.
Oh no. Heating you get N2 if only the anion is an oxidizing agent. If only the anion is in. With HCl you get white fumes. Ammonia fumes in HCl and HCl fumes in ammonia, vice versa. Nessler's reagent K2HgI4, you get a brown precipitate. Iodide of Minions base, don't need to learn the formula. That's all about cations. You are likely to get 2 questions on this. Any bicarbonate, any acid, what is it you get? Carbon dioxide. The 2005 question, benzoic acid, sodium bicarbonate, gas X, This one again with the sodium bicarbonate. Gas Y. What are X and Y? Huh? CO2, SO2, 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 CO2 or CO2, CO2. Why? Both are acids. This is benzoic acid, that is benzene sulfonic acid. So how do you get this? Bicarbonate combines with H plus to give H2CO3, which is nothing but a mixture of CO2 and H2. Identification of anions. What is the procedure? Anion acidification with suitable acid. Which is a suitable acid? I say it is like capping the anion, giving cap Cl minus, give it a H plus, it becomes HCl. You get acid molecule. And very rarely a gas or gas. When you heat that, what is it you get? What happens when an acid is heated? You will get its anhydride gas. Mostly anhydride gas. And you test for that gas. You conduct tests for that gas. The anions, it's bicarbonate, carbonate. These two are not there in the syllabus. I tell you the reason later. Sulfite. Then comes sulfide. First three are not there in the syllabus. Nitrate, Cl minus, Br minus, I minus, SO4, 2 minus. We in fact have three sets. First set, second set, third set. Which acid is suitable for them? Stronger than all of them. HCl. You add dilute HCl, which produces H plus. What is it? You get H2CO3. On heating, you get CO2. CO2 with lime water gives a milky white precipitate. What is CaCO3 called? Limestone. Most of the hills in India are those of limestone only. They are not granite. Limestone. And when it is powdered not by grinding, powdered by strong heating, 1000 degrees, you get CaO, which is called quicklime. The one we use to whitewash the walls. Now, small amount of water, what you get is called slaked lime. Where is this slaked lime used? Construction in place of cement, before cement was manufactured. Slaked lime. The old constructions even today contain slaked lime. And when this slaked lime is added to chlorine and hot air, there will be rakes, one below the other. Rakes. Slaked lime is dropped from the top and chlorine and hot air sent from the bottom. And they will be rotating rakes. When they rotate, the slaked lime mixes with chlorine, and what you get eventually? Bleaching powder. This is how bleaching powder. CaOCl. And lot of water. When you add lot of water, what you get is called lime water, and this lime water is used for whitewashing. Now, this milky white precipitate, when CO2 in excess is added, dissolves. What is this milky white precipitate? This is calcium hydroxide, and this is calcium carbonate, and this is calcium bicarbonate. And as I told you, all bicarbonates are soluble except sodium bicarbonate. Next, for CO3 2 minus also the same old story continues. That is why you cannot say whether it is carbonate or bicarbonate, therefore they are not there in the syllabus. Now, why is sulfite not there in the syllabus? Sulfite, because it is a reducing agent. Suppose if you take ferrous sulfite, it gives results for ferric sulfate, because sulfite, if you take ferric sulfite, it gives results for ferrous sulfite, reduces ferric. So you get H2SO3. On heating you get sulfur dioxide, and dichromate paper is turned green. SO2 turns dichromate paper green. What is this paper business? Why do you need a paper? When a gas is released, how can you allow that to dissolve in the liquid of solution of potassium dichromate? Therefore, rather than taking gas to the solution, bring the solution to the gas. Take a dichromate paper, just add some water and put that above the test tube, and it turns green. The only gas that turns dichromate paper green is sulfur dioxide. There are many people who can do this job. For example, ferrous reduces dichromate to chromium 3+, which is green. Cyanide, bromide, iodide, But all of them are solids, my dear friends. Cyanide, you have to take KCl, potassium cyanide. Bromide, some bromide you have to take. Iodide. So, there are many people who reduce sulfur dioxide, but the only gas that reduces. What about H2S? H2S also reduces dichromate paper green. You get Cr3 plus green, but H2S, all reactions of H2S, you get yellow, white turbidity of sulfur. Yellow, white turbidity. Please make a note, this is important. And Cr3 plus green. So no doubt you get green, but this is yellow and green. Yellow, white and green. That's a very important reaction. And in all likelihood, this year it might come. From reactivity, you will get 2 questions. Qualitative, you get 2 questions. 1 question from practical organic chemistry. Watch that video on that YouTube. I was told that all the 50 hours are put by Prime on the YouTube. 50 hours of recording. I think I taught metallurgy for an hour and a half. Watch metallurgy. Or if you want, I will do that today again. From ores and minerals, you will definitely get 1 question. FeCr2O4, what is that called? Chromite, good. FeCr2O4. It's a mixture of FeO and Cr2O3. And how do you get potassium dichromate from that?
Cr2O4 plus O2 plus Na2CO3, we get Na2CO3, we get Na2CrO4. Then in acidic medium, we get Na2Cr2O7, then KCl, we get K2Cr2O6.
Or simply hydrogen peroxide. You are oxidizing that basically. O2 and Na2CO3. Na2CrO4, chromate I was told.
We can use ozone also.
Any oxidizing agent. And you underline that's done in basic medium. Acidic medium में reduction होता है, basic medium में oxidation होता है. Chromite rock. Now, sulfide, you get directly H2S gas. Smell of, what is the language used for this? Smell of rotten eggs. And turns lead acetate paper block. And once again, there are many people who turn lead acetate black. I told you all cations black, but the only gas that turns lead acetate black. For example, magnesium sulfide turns lead acetate black due to the formation of lead sulfide. sodium sulfide, lead sulfide. So there are many, but all of them are solids, the only gas. So in qualitative analysis we have to take a unique reaction, a reaction given by that particular cation or anion only. Nitrate, what is it you get? HNO. And of course there is another confirmatory test for this, and which I will teach you immediately after this. HNO3, this unheating will give N2O5, and further heating you will get N2O4 plus O2 and NO2. All this happens on heating only. NO2, and this is a reddish brown gas. Confirm with brown ring test. Brown ring test for nitrates. And which acid is suitable for these three? HCl. Can it protonate Cl minus? No. This is also HCl. One HCl cannot protonate another HCl, cannot give a proton to another HCl. Therefore you have to select a stronger acid than these three. So this one it is H2SO4. Dilute or concentrate doesn't matter, because eventually we are going to heat and it becomes naturally concentrated. Now you get HCl. HCl fumes in ammonia. This time you get Br2, reddish brown gas. With silver nitrate you get pale yellow. What is the difference in these two reactions? Please tell me. Sorry? हुआ क्या? Br minus oxidizing agent? Br minus oxidize हो गया. And I told you H2SO4 will not oxidize everyone. किसको oxidize करेगा? Cyanide, bromide, iodide. Cyanide and his friends. Who are they? You know the pseudo halides. Cyanide, isocyanide, cyanate, isothiocyanate, वगैरह वगैरह. The pseudo halides. Azide. So I minus also gets oxidized. I2, violet vapors. And with silver nitrate, the solution gives. Who gives a pale yellow with silver nitrate? It's not Br2. It is a salt solution. Salt solution plus AgNO3. This time we get a clear yellow. And you know neither HCl nor H2SO4 can protonate sulfate. And there is no stronger acid than sulfuric acid. Of course there is HClO4. So when HCl is added and H2SO4 is added, nothing happens. No gas is occurring. It's naturally sulfate. And the only test for sulfate is with BaCl2 you get a white precipitate. So we have confirmatory tests for sulfide, nitrate and chloride. And what is that 2009 strange question on sulfide? Para-amino N,N-dimethyl-aniline, methylene blue, which nobody knew. We all searched in the net for that. Yes, you may put that also. I2 turns starch paper black. Starch paper black, and that's very important. Thanks for reminding. Starch paper black due to the formation of starch iodide. I2 turns starch paper black. Starch paper blue. Hey, I do eat cap breakfast never. Yes, sulfide. Other than him, how many of you remember the test, conformity test of sulfide? 1, 2, 3. Na2, Fe, CN5, and O. This is called sodium nitroprusside from Prussia. Sodium nitroprusside. You get Na4, FeCN5NOS, which is called sodium thionitroprusside. Thionitroprusside, and which is violet complex, violet color complex. So there are many violet colored complexes, but sodium nitroprusside giving violet with sulfide only. Confirmatory test. And another para-amino N,N-dimethyl-aniline. N,N-dimethyl-aniline. Please don't learn this. This is a one-time wonder which is never going to be repeated. Now, para-amino N,N-dimethyl-aniline gives blue coloration, methylene blue, with sulfide. Don't write this, please. देख रहे हो? वो रद्दी गैदर करने का आदत बंद करो. तो म्युनिसिपैलिटी का घंटा गाड़ी थोड़ी हो. So that's one bad habit students have to stop. Trying to learn whatever that comes across, and especially which appeal to your eyes. अरे अजीब सा लग रहे. Na minus, sodide ion, sodide seaside, suicide. Next, nitrate. When this nitrate is treated with natural H2SO4, what do you get? HNO3. And HNO3 on heating gives N2O5, ends on getting NO. And when that NO is treated with FeSO4, you get Fe H2O 5 times NO 2 plus. What is the oxidative state of iron here? Plus 1. Because NO is NO plus. Why? NO wants to become NO plus because bond order increases from 2.5 to 3. 5 big zeros. And this is a brown ring is formed. Did any one of you get this in the laboratory? Brown ring? This is the only test we get clearly. Of course, I never handled test tube in all my life. Even as a Sarkari teacher, I used to take all the theory classes and the 3 others used to take practical classes. Now, chloride. Chromyl chloride test, very important, my dear friends. For soluble chlorides only, which produce chloride ions, very important. Listen, which between these two give chromyl chloride test? Huh? Why? Allyl chloride ionizes in water. Tertiary allyl benzyl halides ionize in water. Tertiary allyl benzyl chlorides ionize in water and produce halide ions. Now, K2Cr2O7 plus H2SO4. Orange red vapors. The orange red vapors could be because of CrO2Cl2 or Br2 or even NO2. Assuming you have NO2 minus, you may also get that. So orange red vapors. Now, in this chromyl chloride, Cl minus, between Cl minus and chromium, who is the oxidizing agent, who is the reducing agent?
No one.
Why?
Because Cl minus are oxidized by only 4 Km4 and 2 O2 and
That's true. Not only that, Cl is -1 here, -1 there. Chromium +6 in both the cases. This is not a redox reaction. Now, CrO2Cl2 with NaOH gives sodium chromate as usual. Yellow solution. All chromates are yellow. And with lead acetate, you get PbCrO4, yellow precipitate. अगर वो ब्रोमीन होता NaBrO, colorless. How does NO2 react with NaOH? Anybody? What's the product? NO2 plus NaOH.
NaNO3 plus
N2. N2.
No, NaNO3 and NO2.
NaNO3 and NaNO2. Why? Why did you get two salts?
पढ़ा था थोड़ा कि NO3 on reaction थोड़ा सा लास्ट ईयर भी तो आया था.
Why do you get NaNO2 and NaNO3? You are getting two salts. Means there are two acids. NO2 is a mixed anhydride of HNO3 and HNO2. HNO3 and HNO2 minus H2O. This is N2O4, a dimer of NO2. Therefore, since it is mixed anhydride of two acids, you get naturally two salts with base. NaNO3 plus NaNO2. How do you get this chromyl chloride? What are the steps? First step, Cl minus gets protonated by H2SO4, you get HCl. Next step, dichromate, Cr2O7, also gets protonated. Acidification, you get dichromic acid. And this dichromic acid undergoes hydrolysis, HOH, and you get chromic acid. Dichromate, this one, dichromic acid on hydrolysis, acidic hydrolysis of course. You get chromic acid. And this chromic acid will react with HCl, giving chromyl chloride. What is the last reaction? What is the last reaction? Acid-base neutralization. Chromic acid is made to behave. Chromic acid is made to behave like a base in presence of the strong HCl. So what is chromyl chloride test? It is eventually acid-base neutralization. It involves acidification, hydrolysis, acid-base neutralization. All steps. Okay. That's all. How do you identify lead sulfide?
H2O2, black stains.
Lead sulfide. Suppose you are given lead sulfide. For your touch it is heavy. Density ज़्यादा है ना lead का, lead sulfide. When you add dilute HCl, lead gets precipitated. When you heat, lead dissolves and H2S gas comes. Test for H2S bus. Within first step, 1 second, your lead sulfide is identified. Even in the solid state, it smells of that rotten egg, H2S, because it absorbs some moisture. a hygroscopic salt. Practical organic chemistry. Want this or not? China? How many of you remember? What is the test? Lassane's test, and of course Middleton's test we don't have. Unknown organic compound. Small quantity of. Now, how do we get these unknown compounds? Huh? Suppose in the Brazilian rainforest, people get treated from a particular disease using the leaves and the barks of a particular tree. What we do is collect those leaves or bark or roots, put them in water, and we start heating. What happens? The soluble, if there are any soluble ionic compounds, they dissolve, and we are not worried about them. And most of the organic compounds are insoluble in water, and they form a layer, turbid layer, less dense. And you collect the oily layer, and using fractional distillation. Last year also I reminded students to learn the separation techniques. This year is very important. Separation techniques, you remember that? What is that? Fractional distillation, distillation under reduced pressure. Chromatography is not important. No. So, when you slowly distill that, at a particular temperature, a particular gas comes. And I am telling you, no two substances have the same boiling point unless they are optical isomers. Optical isomers cannot be separated by fractional distillation. That's a good question of 2006. 2006 में बहुत कम good questions है. This is one among them. So, at a particular temperature of 44, some vapors are coming, and you refer to your manual. Okay, 44 यहाँ ये है ना, ये मालूम है, ये कुछ कैंसर को ट्रीट नहीं कर सकता. So, at a particular temperature, you get a compound which hasn't been identified until then, and that must have been responsible for the disease treatment. Now, so you take small quantity of that unknown organic compound. Why small quantity? Because we get those unknown substances in small quantities only. You don't get tons and tons of them to start with, and we have to make more experiments on that. We have to reverse engineer that, find the structure, etc. Now, unknown organic compound and pea-sized sodium means it is a actually इतना organic substance लिया तो इतना sodium बहुत ज़्यादा लेना है, 100 times more. Now, in a small ignition tube, small test tube, छोटा सा, तुम्हारा पेन की कैप की जितना, and heat very strongly heat very strongly until the test tube also melts. Test tube तक पिघल जाएगा and you get a solid mass. You grind that. Grind, powder, add water, filter. फिल्टर जैसे क्या होता है, कांच वगैरह फिल्टर हो जाता है एंड इवेंचुअली गेट फिल्टर करो. The filtrate is called sodium fusion extract or Lessines extract. Lessines extract. मेंस में कितना नंबर है? 260. केमिस्ट्री में कितना? 85. फिजिक्स? अरे सबको फिजिक्स में ज्यादा है, तुमको कम कैसे? मैथ्स 100. बढ़िया. Lessines extract. क्या कर रही है? पहले 2 बार लिखा होगा, रिपीट नहीं किया. So very sure to get one question from practical organic chemistry. If you are lucky, you may even get a matching. एक बार आया 2010 I suppose. And even the 2009 question also is nothing but POC. Hexacyanoferrate 2 is added to X to give intense blue coloration, Prussian blue. 2 inside है तो 3 outside. This Lessines extract अगर the compound contains nitrogen and many more elements, OH, Cl, compound may contain many elements. What happens when that is heated? When heated, all bonds are broken. You know, even at 150 degrees, all bonds of organic are broken. And all carbons may even become CO2, H2O, and nitrogen may escape as N2. Chlorine is separated, but at least some of the carbon and nitrogen combine with sodium to form sodium cyanide. Listen to me. Na2O itself is difficult. What do you mean by that? Oxygen cannot sustain 2 sodiums, the positive charge of 2 sodiums. Sodium is so highly positive that one oxygen cannot handle 2 sodiums, therefore it forms peroxide, Na2O2. 1:1 ratio. मैंने बताया ना, Li2O टोटल लिथियम का 2 दोसा खाना है क्योंकि बहुत छोटा है. टोटल सोडियम का तो राइट साइज है. टोटल पोटेशियम फैमिली डोसा 70 mm, 2 लोग खाना. Therefore, potassium forms KO2, superoxide, peroxide. Okay, that's a different matter. So, Na2O ही मुश्किल है. Even Na2O is difficult. So we can't imagine Na3N. A good student like oxygen cannot sit for 2 hours in sodium's class because sodium teaches so high. Even a good student like oxygen cannot tolerate, cannot withstand 2 hours of that fast bowling. And you can't expect nitrogen to face 3 hours and carbon to face 4 hours, Na4 से. ये नामुमकिन है. Therefore, to face that batsman, bowler, 2 batsmen are playing. Carbon and nitrogen. Carbon, nitrogen दोनों मिलके साथ में खेलेंगे. They will oppose him. Therefore, Lessines extract. If the compound contains nitrogen, Lessines extract is nothing but extract is nothing but NaCN solution. And you should know all compounds of all alkali metals are soluble except sodium bicarbonate. Repeat. All compounds of all alkali metals are soluble except sodium bicarbonate. Sodium bicarbonate can be obtained in solid state. Now, and you now test for NaCN, FeCl2 aqueous. You get Na2, FeCN6. I don't remember the color. Is it Na2 or Na4? Na4. K4 FeCN6. First iron 2, then just air and heat. Iron 2 becomes iron 3. You get ferric ferrocyanide, Fe4 FeCN6 thrice. Ferric ferrocyanide. Prussian blue. Prussian blue. How to remember the formula? 3 outside, 2 inside. Three outside, 2 inside. Chai. If the compound contains sulfur, Lessines extract is nothing but sodium sulfide solution. And you test for sulfide. So by default, we have cyanide also in our syllabus. Cyanide, thios, chai. Jaldi. Na2S. You add once again the same. Na2Fe, CN5NO. What is this called? Sodium nitroprusside. You get Na4, FeCN5NOS, sodium thionitroprusside, a violet colored complex. Can you adjust this? गिर गए. What is this for? Stop the light. The reflection. Yes, if the compound contains nitrogen as well as sulfur. Hey. एक ही रूम है. Nitrogen and sulfur is nothing but NaCNS solution, thiocyanate. Now, and the sodium thiocyanate, how do you test? Iron 3 के साथ. Iron 3 के साथ blood red, FeCNS 6 times 3 minus. You get that blood red. So don't expect the entire compound to be converted to sodium thiocyanate. Small quantity. That's too because we have taken a lot of sodium. Sodium is more abundant than the organic compound. If the compound contains halogens, Lassane's extract is nothing but NaCl, NaBr, NaI. How to test for them? Ag and with AgNO3, AgNO3. This fellow gives white precipitate, pale yellow. Fellow gives yellow. कौन सा? Prussian blue is color. Precipitate. Color of the precipitate. Solution naturally colored रहता है ना. Sodium chromate. हाँ. Sodium chromate is a solution and lead chromate is a solid. Here also Prussian blue is formed in large quantity, therefore it precipitates. थोड़ा solution में भी रहेगा, थोड़ा precipitate होगा. Look here. Lassane's टेस्ट में हाइड्रोजीन क्या कलर देगा? क्यों?
does not contain carbon.
लाइसेंस टेस्ट फॉर इज फॉर ऑर्गेनिक कंपाउंड्स. कार्बन देखना है, तो कार्बन है ही नहीं. नाइट्रोजन देख के प्रूशियन ब्लू नहीं बोलने का. सो पैरा एमिनो एन डाइमिथाइलिन in presence of FeCl3 gives blue coloration. After that, X with potassium hexacyanoferrate 2. Potassium hexacyanoferrate 2 gives intense blue color. He never used the word Prussian blue. So, what is X? 2 and 2 inside. This is 3 outside FeCl3. And X reacts with potassium hexacyanoferrate 3. To give Z. What is Z? X again is FeCl3. So 3 outside, 3 inside. Therefore Fe, FeCN6 bus. Brown. We don't need to know the color because he mentioned. 2009 question. Okay. What else? You remember the 6 points of coordination compounds? All palladium 2, platinum 2 complexes are square planar in their 4 coordination. All palladium 2, platinum 2 complexes in their 4 coordination are square planar diamagnetic DsP2. Huh? Cu? Tetramine copper 2. Tetramine copper 2. Only with ammonia. And ammonia behaves as a strong ligand only with 3 C's. Chromium, cobalt, copper. Don't worry about chromium 3. Chromium 3 complexes. Which are strong ligands? CO, Cn minus, NO plus, PPH3 and all polydentate ligands are always strong. Which are weak? F minus, Cl minus, Br minus, I minus H2O are weak. Ammonia strong with chromium, cobalt, copper. All others, I don't know. Huh? Oxalate, मालूम नहीं. H2 बाद में मतलब weak आएगा. Water in that spectrochemical series doesn't give you the strength of ligands. It all depends on the color, intensity of the color they produce. H2O is given ahead of oxalate because H2O is not only ligand but also the solvent. Solvent भी है ना, बहुत सारे रहेंगे वाटर मॉलिक्यूल्स. जो कॉम्प्लेक्स का अंदर 6 है वो छोड़ के सेकंड स्पीयर, थर्ड स्पीयर, फोर्थ स्पीयर में रहेंगे ना. चल paramagnetic with 3 unpaired electrons. Look here. Iron 1, iron 26, 3D. कोई नखरे कर रहे हो? 3d6 4s2 FeH2O 5 times NO 2 plus, in which iron is +1. आयरन प्लस का कॉन्फ़िगरेशन क्या होगा? 3d6 4s1. And NO occupies, only NO is strong ligand, and NO only forces this electron to go away. Forces this electron only. बहुत अंदर नहीं आएगा, इसको इधर भगाएगा. And NO occupies this place. Water, of course, sp3d2, water, water, water. sp3d2. Paramagnetic with 3 unpaired electrons. I think the question is given in 2008. Okay, stop the camera.